Hi everybody, welcome to the big talk of the night, I guess. How about another round for Charles? Great presentation, Charles. Thanks for getting up here and talking about it. You know, it's not easy to always get up in front of a group and talk and do a presentation like that. And actually I found it very interesting. One of the groups that I manage in my day job is a Kubernetes security group, and we're starting to look at Open Policy Agent, Rego, and some of those things. So it was really interesting. So my name is Brent Laster, and first off, thank you to everybody who has come out tonight for the talk, and thank you to everybody who is online as well. Hope everybody's able to hear and see and all that good stuff. I won't do the obligatory, can you hear me, can you see me, because hopefully we'll be able to detect that if that's not the case. And thank you to Todd and the All Things Open team for inviting me out here to do the talk tonight. It's always a pleasure to work with Todd and the team. I can't say enough nice things about them. Just if you'll indulge me for just a second, a little story, and I was going to mention this to Todd at some point too. One of the companies that I do a lot of work with in my training is O'Reilly. Anybody know O'Reilly Media stuff? So I was connecting with a new editor this morning. I had an 8 o'clock call with her because she's in London, and got on a call with her. And one of the first things she said to me was, "Oh, I see you've done some things with All Things Open." I said, "Yeah." I said, "You know about them?" She's like, "Yeah, I was a speaker back at a conference in 2016 for another company." So one of the most incredible things I think about the All Things Open company or the group organization is the sense of community they build. I guarantee you, if you come to the conferences, if you're in the meetups, those kinds of things, you will run into people all around the world, all around the country, who have been to All Things Open, recognize the merchandise, just or say, "Oh yeah, I was there in such and such a year," or something like that. So if you get a chance to come out to the in person to the conference in October or online, I really encourage you to do that. I'll be there doing a presentation. Hopefully we'll be doing, I think, some book signings too, right? Yeah, cool stuff. So always a great organization to work with. And thank you to Todd and the team for providing these and for inviting us here to speak. So, a little bit about me. I guess that's a lot about me. I'll go through this quick, I promise. My day job is as an R&D director in a DevOps organization, a company called SAS up in Cary, North Carolina, about 4 hours up the road. I am doing this under my own kind of training company and stuff, but my day job is SAS. SAS is a sponsor of All Things Open this year as well. Do a lot of global training. Have a company I do that under Tech Skills Transformations, training in Kubernetes, CI/CD, Git, all sorts of things, GitHub Actions now. Have a couple of books out there, some mini books on O'Reilly, and maybe of interest to folks in here for this talk, there's a book on GitHub Actions I'm working on with O'Reilly, which should be out. They've got it right now for 2023. We're kind of holding on it to get some of the latest and greatest things that are going to be in GitHub Actions. But just yesterday, the first 2 chapters came out for early preview on O'Reilly. So if you're interested, go out and check that out after the talk or something. And maybe if you've got some more interest in learning a little bit more about it than we got time to cover here, those may be of interest to you. Other books I've got, there's a professional Git book, where there's lots of Git resources out there. This one's on Amazon. Jenkins 2 book for CI/CD, pipelines as code, all that sorts of things. Jenkins is still a thing, still around. If you get this one, just recommend that you get the electronic version, because the printed version has some screenshots that got kind of washed out when it was printed and stuff. So, and then here's the early release, chapters 1 and 2, learning GitHub Actions on O'Reilly. So they'll be putting out more chapters as they go along. So in case you're interested in that, feel free, if you've got an O'Reilly account or something, to get on and check that out and look at the first couple of chapters, and we'll add more in there. All right, so this year, ATO 2022, I'm going to be speaking there, doing a course on Tekton, or a presentation on Tekton. So if you're around for that, Tekton is CI/CD in Kubernetes, basically coding up CI/CD pipelines as native Kubernetes objects in there too. So if you're interested, check that out. Lots of training on O'Reilly. If you're on there, check it out. Also do some stuff for a group called No Fluff, Just Stuff. Doing like a 3-day Kubernetes boot camp in November, and some other virtual workshops on there. So anyway, point being, if you're interested in more training or some of the topics talking about, just search for my name and you'll find it. All right, so let's get into the main topic you came here for tonight, for this part of the conversation at least, GitHub Actions. So let's start off by talking about what are GitHub Actions. And the easiest way to kind of characterize them is that they are ways to create custom automated workflows in GitHub. You know, GitHub has the whole ecosystem around the Git hosting repositories. It has the issue tracking. It has the pull request. It has editors built in. It's that sort of thing to try to keep you in the GitHub system, in the GitHub interface and ecosystem when you're in there. One of the things that it has been missing, though, was really that sort of automated way, that way to do things like CI/CD directly from GitHub. In other words, you made a change into your source code repository to have things kicked off and to have things go off and do the typical kinds of building and testing and such in there. There were lots of other options that you could plug into or connect up to it, things like Jenkins or GitLab or Travis CI, Circle CI, a lot of those things that would interface with it. But GitHub was really missing that sort of built-in functionality other than by doing things like through API calls and such to be able to have these kind of automated workflows. And that's what GitHub Actions really gives you. Now, a quick note about this, when I talk about actions here, actions refers to both the overall framework that is these automation piece of it, and it also, an action is an individual piece that you can call, an individual workflow part that you can call there too. One of the guys at Microsoft who I've been working with a little bit on this said that his convention was more to say, when you talk about the overall framework, we'd use a capital A. When we're talking about the individual pieces, we use a lowercase a. So I'll try to use that convention throughout here. I think I've got most of that done, most of the slides. Can't guarantee all of them. But GitHub Actions are typically thought of more in terms of a CI/CD, continuous integration, continuous delivery. Some event happens in the repository or in something in GitHub that you're interested in watching or triggering work on, and then the GitHub Actions turn around and do some automated processes. It might be an action that checks out the source code. It might be an action that builds something with Gradle. It might be an action that scans your things for security. You know, think of it almost like plugins for other things, like with Jenkins or Orbs and Circle CI, any of those kinds of things. It's these automation pieces that you can trigger off of something happening in GitHub and executes in GitHub to do the automation pieces for you. They're building blocks. They can be combined and shared. Really useful for SDLC, software development lifecycle, for the whole lifecycle pieces, from making the code changes all the way to being able to deploy, to test all the pieces in their development. And it can be used for CI/CD as an alternative to some of these other apps. Some example use cases, and these are based off of what we call starter workflows. Now, the term workflow in the GitHub Actions world essentially means an automation script. It's really a YAML specification. Everything's YAML these days, right? It's YAML specification, sort of like a script that's going to run and go and run through jobs and run through steps, all those kinds of pieces we'll talk about in just a minute. But you can see, if you start with just a basic workflow, or you want to start with with no actions, GitHub will suggest to you some things that you can starter workflows for you. Things around deployment, security scanning, continuous integration, automation, all of these kinds of things. And it's sort of like in the Jenkins world, if any of you ever used Jenkins before, where if you want to be a player in the Jenkins space, a company will produce a plugin for it, right? You'd have a plugin for Git, you'd have a plugin for Gradle, whatever the case is here. And so we have workflows now which are for these various kinds of pieces, and you'll find ones out there from different companies as well. For example, there are ones from Atlassian for doing things with Jira, if you want to automate creating Jira issues and sort of those kinds of things. So lots of different starter workflows that you can just sort of say, I want to start with this and have the basic pieces going and then add to it. What's interesting about it? Well, lots of things are interesting about it, but direct integration with GitHub. This is really probably why you would use GitHub Actions is if you are managing your repositories in GitHub, right? Because if you're already in the GitHub space and you're already having everybody working in there, it has very tight integration with GitHub, as we'll see through the interfaces, through all of the code repositories, all the pieces in there. This is really about supplying that missing piece, that automation that you can key off of within GitHub and managed by GitHub, and it can even be running on GitHub's own machines. We talk about runner systems, or systems that GitHub will stand up for you, virtual machines, and execute the code for you and then tear them down there. So you can have GitHub doing everything for you with this. Direct integration with GitHub. What's shown on the screen, sorry, it's kind of hard to read probably on here. There is, and this is a GitHub repository, and on the code tab here, has everybody before kind of worked with GitHub? Hopefully we've seen it, or at least they have some familiarity with it. In the code repository there, GitHub Actions, or these workflows, I should say, the workflows that call the actions in there, are stored in a special directory called .github workflows. You know, every open source tool these days seems to put things in directories, you know, .git or .gradle, whatever it is in there too. And there's a .github area here, so .github workflows. That's how you associate an action, a script, workflow with the particular repository. So it's integrated right in that repository, just in a special directory. There's also an action, if you go into that, you can see it's a couple of YAML files here. These are YAML files. These each implement a specific workflow, like one to create an automatic failure issue. One I wrote to automatically create a GitHub issue when there's a failure detected. I can call that workflow to do that. Or a simple pipeline one there too. There's YAML specifications. We'll talk about the format of these more as we go along. But they're housed with the repository in that .github workflows area. Now when we actually, and the other new thing that you have in your repositories now is you'll have an Actions tab, an Actions section of the repository. And that's going to let you do things like go in and look at the different workflows that you created to associate with that repository. Also let you see the runs of them. I relate some of these things back to Jenkins because that's probably something most people are familiar with. If you know when Jenkins, when you run the jobs, you get to see a record of the runs, you get to see what the inputs was, the outputs, the successes or failure. Same idea here. You have the sort of log of the workflow runs and whether they succeeded or not. And then you can also even go into individual runs and you have like a graph showing the different parts of this, how the different parts are connected, the different jobs that we have in the workflow and how they're all tied together, whether they succeeded or failed. And you can drill further into it. And you can even get down to the logs and see the commands that have been run on the runner system or on the system where the job was executed. So that is all integrated into the GitHub repository. In that Actions tab, you can get through all of the outputs, drill in to see what happened, the success or failure, and so on. You can also initiate runs sometimes from that as well. So what else is interesting about it? Lots of events can trigger an action workflow. You can automate pretty much anything that you can do in GitHub. You can have an action workflow that will automate something based on that. For example, you can have it on a project or on a watch, on a repository dispatch. Repository dispatch, workflow dispatch, these are things that where we actually would go and kick off the workflow manually. And then on delete, on a check run, on page build, on scheduled, pull request, all the different kinds of things that you might think of to do in GitHub. Now most of the time, a lot of these things will be keyed off of something that actually makes a change in the repository. Ends up making a new commit in there, creating a new change in code, like a SHA-1 value, new commit record in there. But it can also be things like a pull request gets initiated or a comment gets added to a pull request. All these kinds of things. There are a lot of different events that you can key off of. There's on pull request review comment. So you can automate pretty much anything that happens in there so you can then have whatever you want to have happen or to automate off of that. Types of triggers for events. With the on, by the way, that's the keyword in a workflow definition in the YAML file that says these are the things that I am going to key off of. On says when this happens, then I'm going to key off of that. I'm going to go off and initiate the workflow from there. You can have a single event like an on push. You can have standard sort of YAML format. You can have a list of events like on a push or a pull request. You can specify activity types based on particular branches in there. You can have scheduled events, so like run on a cron syntax. You can have manual events, workflow dispatch, repository dispatch. You can have different things for other workflows or webhooks or such in there. So again, the point being, there's lots of different ways to invoke these workflows, and pretty much anything you can do in GitHub, you can key off of and then have something automation to run with that. How actions work. So starting out, we're going to show you pictures here and go through constructing how the workflow is, or how the flow is from an event happening to how it gets executed in GitHub. So we start off with the events. An event could be an example of a pull request, triggers a build for validation, or somebody does a push for a commit, or some kind of repository dispatch event. Or any kind of activity that activity is not in GitHub. You can even trigger workflows based off of those kinds of things. But essentially, an event happens. Something happens that you are interested in triggering automation to run from. So the event happens, and then in your GitHub workflows, you would have a YAML file, and you would have things like you'd have a name and such, and we'll talk about these other pieces in a minute. But you can see here the triggering event on, and then on a push to the main branch, or on a pull request for the main branch in there, or on a workflow dispatch. Workflow dispatch just means I can run this manually. I can run this manually and supply some values and kick this off from the actions menu. So these are the kinds of things here that will trigger this particular workflow to run. So this workflow is housed in that GitHub Workflows area, but the key here is that these conditions, this is what tells GitHub when to execute this workflow. So if I have a push or something on a different branch, that's not going to trigger. It's only going to be on main. So this is how you can have multiple workflow, those YAML files in there, but you can use the on conditions to decide on what particular events and which branches and stuff you want to run on. So, and this is another partial list of some of the things here, and I don't even know what some of these things are, to be honest with you. Golem, I need to look that one up, but you can see issues, page build, pull request reviews, push, registry, release, so on, all kinds of things in there. Again, pretty much anything you want. So moving on, after we have an event that occurs, then the event is going to match up, if the event matches up to one of those on clauses in there in a workflow file, then it will trigger that workflow. So you can have, again, multiple workflows, but if GitHub will go through and say, does what happened, does the event, does it match up to any of those on conditions that you've got in those workflow files? And whichever ones it does, then it can go off and trigger those. So the workflow, think of that like your script or like your pipeline. That's probably the easiest way to think of that. That's your over-encompassing script or your pipeline in there. And when you have the workflows, this is really what we're talking about. Even though we talk about it as GitHub Actions, the actions are kind of the individual pieces that we can call from steps or the overall framework. It's really about the workflows when you're talking about defining the automation. So the workflows here, like I have a simple pipeline here, and if I did a push onto that, then it would trigger that pipeline, it would trigger the on condition, and it would go off and do whatever steps were defined in that workflow file. And then you would see it in the run in the actions tab, see the output from there, information about when it got kicked off, how long ago it ran, was it successful, which branch, and so on. Then moving on from actions, from events and workflows, workflows contain jobs. So jobs are kind of like your individual projects, your individual functions or procedures. So we have the workflows there, and then we have the jobs, and the jobs then can contain steps. So a step is sort of the lowest level granularity that we get to in a workflow file. And a step is either going to be a call to a GitHub action, in other words, something that somebody has implemented as an actual action in there, a piece that they can call, functionality, or it can be a shell command. So when we talk about what this looks like, it's the events, and I know it's kind of hard to see here on the slides, but I'll make the slides, copy of the PDF of the slides available to you. I'll just point out here, there is a section here at the top, there's a name, this is a workflow file. So this would be some .yaml file, pipeline.yml or something you would put in that GitHub workflows area. There's an on clause there that says under what events do we trigger this to run on. And then there is a job section. And then there's a job here called build. And that is going to obviously do a build. So the build job then has steps in it. And there's a couple of steps here. You may not be able to see it well, but the first one says uses. The uses clause is how you say, I want to use a predefined action. I want to use an action that somebody has defined. In this case, the action is called checkout. Now it says uses actions at checkout v2. What that really equates to is there is an actions organization in GitHub, and then there's a checkout repository underneath that. So GitHub itself supplies some actions for you. You can also have people that have written other ones. You can write your own. You can use it in there too. The uses clause brings in or calls that action. And then there's also another one here, uses action setup Java at v1 with Java version. The with just means the parameters. That's how I supply parameters for that. Then on further down here, there's another step. Everywhere this dash starts out, there's another step here. Grant execute permission for Gradle W. It just says run. We're just calling a shell script, or calling a shell step rather in there. Change mod, chmod, and then a calling Gradle W. So a step is going to be either a use of an action, existing action, passing in some parameters, or it's going to be running a shell command. And then steps are housed within a job. So how do you define a job? Well, it's the same kind of thing as you might do, again, if you use like Jenkins or something, that sort of project level thing. If you have a job for a build, a job for test, maybe a job for deployment in there, that granularity, sort of the granularity where you want to know if that succeeded or failed. You can go in and debug it from there. What the other thing about jobs though is jobs, each one of them will run on their own virtual machine. So when you're executing a workflow, each job gets a machine fired up for it, started up for it, a virtual machine, runs and executes the code in that job, and then the system goes away. So each one of those runs on a separate machine, separate instance. So then we have the workflow, the jobs, and then we have the steps within there. And the steps, again, can be either an action or a shell command in there so that we go off and execute it. So this is sort of the overall structure. Again, if you've ever put together any kind of like CI/CD pipeline or such, you've probably done something similar with this. We have a project or a piece that does the build, does the testing, does the deployment. That's the kind of the job level, and then the steps are either calling a shell command or pulling in an action to use that. So the action is a set of independent commands based off a repository in GitHub. So actions themselves, when we say uses checkout v2, that's a set of code that somebody wrote to say this is an action you can call and it's going to check out the code within the repository. When it says actions setup Java, that's a set of code that somebody wrote to set up Java for you. And there's a special metadata file called action.yaml that defines as an action. I'll show you more about that later on. But just to give you kind of the overall sense of the workflow. Actions are just repositories in GitHub. And they can be public repositories, they can be private in there. You just say use, and really all you're saying is go to this location in GitHub, like actions checkout, and get that action that's defined in that repository, and I want to use it in my workflow. Let's see, let's go into talking about runners. So runner is the GitHub Actions term for the system that's going to execute the code. What happens is with runners, it's basically a system that is set up with an app on it. Much like you might have any kind of automation tool, like a Jenkins system again. You have an agent on it, a piece of code on it that's going to allow it to communicate back and to be used as a node for a Jenkins system. Same idea. We have the Actions runner, the app that is installed on these machines, and then they can execute the code on it. Now you can use the runners provided by or hosted via GitHub, or you can use your own. GitHub, unless you tell it otherwise, is going to go off, and for each job in your workflow, it's going to start up a new virtual machine. It's going to start up a new VM, run the code on that VM, get rid of it, and then go on to the next job. So GitHub will do this for you. They'll supply the runners for you. If you have public repositories out there, you can just use the runners there. You can also have your own self-hosted runners. Self-hosted meaning you have a system in your company or in your organization, whatever in there, and you put the GitHub app runner on it, GitHub Actions app on it, and you tell GitHub about it, and then you can send code to it. So you can host your own runners if you need to do that, if you want to take on that responsibility or to have more control over it than what GitHub will provide, or you can have just GitHub to do this for you. So kind of building out our workflow here, all the steps in a job would execute on the same runner. So we have the different jobs in the workflow, the event happens. Each job then has steps in it. Steps are just a call to use a particular action, a predefined action or a shell command. And then each of these jobs gets fired up and run on its own VM. The VM starts up, runs through the job stuff, and then goes away. By default, the jobs are going to run in parallel. You can serialize them. You can say one job needs another one. But it's all happening in the background there on the VMs. So GitHub is actually spinning up these VMs for you, executing the code, reporting the results back, doing all the automation. So again, one of these things is you never actually have to leave GitHub. You are in the GitHub ecosystem. They kind of want to keep you there, and they want to provide all the functionality for you. So you can do all of your CI/CD automation and stuff in GitHub itself. And then the runners, of course, they will run, the action or command will run, results will be logged, the results will be saved off, the success, failure, what happened in it. You can drill into the logs, you can look at the debug into it, and so on. So then the bigger picture here, in our GitHub repository, in the .github workflows directory, we have the workflow files, the .yaml files, with the on clauses that will match up to say when these particular things execute. The jobs are in there. Each job then is defined to run on a separate runner system, has the steps in there, and depending on what the event is that triggers it, then it goes off, fires up the runner systems on GitHub does in the background, or you can have your own runners defined, and then goes off and executes the code, and then comes back with the results. And that's the general flow of things through the GitHub Actions process. So there's actually quite a bit going on, but at the core of it, it's basically like any other kind of script or pipeline you would write. You write the workflow files as YAML files, you say what you want to do, you call other actions, or you have shell commands that you do, and then you just have these that execute on there. And you can actually integrate it with GitHub APIs. You could call other things. I have examples I do in some of the workshops I do where we call into generate the example I was talking about earlier, generating a failure ticket. It calls the GitHub API to actually generate a failure ticket in there. A little bit more about GitHub hosted versus self-hosted runners. GitHub hosted are hosted by GitHub, obviously. Self-hosted, you can use any kind of system or configuration you want to use. Just have to put that runner app on it and tell GitHub about it and say, hey, this system is available as a runner. Direct it to that. Prereqs is for the GitHub hosted, running GitHub Actions has to have the runner application, which GitHub takes care of for you. It all happens transparently if you just use their stuff. GitHub Actions self-hosted runner application, if you're doing your own machine, has to have that on it. Platforms for GitHub hosted, Windows, Linux, and Mac OS. We'll talk in a moment a little bit about the cost difference. There is a cost factor in this if you're using like private repositories and stuff and different multiples based on which one of those you're using. Essentially, they have a pool of machines, and they will periodically go through and rev the versions on them. The Linux version is Ubuntu. And if you have then the Mac and OS, I've got the information somewhere, the Windows versions as well, but they will go through and periodically rev the versions on there. They'll roll it out, you know, when a new version of Ubuntu comes out or whatever, they'll run through and roll it out to different machines. And they have a whole process they go through with that. And they support a couple of versions in there, and you can specify which one you want. So on self-hosted, any that can be made to work, the advantages of GitHub hosted, quicker and simpler, the self-hosted, highly configurable, management ownership in GitHub, of course, as defined, and you get a clean instance with GitHub. Every job gets a new instance of a runner system, spins up, does the work, goes away. I know on your own system, you could choose to have that happen or use the same one again. Cost, it's free minutes on GitHub, plans with a cost for overages. It's free on your own, of course. It's up to you, depending on how much you pay for the infrastructure and such in there. So anyway, you get the idea. For automatic updates, GitHub, again, does this kind of rolling process where they'll periodically update the version of the operating system on there, in there. So GitHub Actions runners, this information is probably a little bit out of date since I did this slide, but just to give you an idea of how this works. When you have the workflow file, and I'll show you another example of that in a few minutes, I'm sure I've got another one here somewhere, you say runs on. Every job that you have in your workflow has a runs on. It's basically saying, what kind of a system do you want us to execute this on? Do you want us to execute on a Windows system or on a Linux system or on a Mac OS system? This, at least at the time I did this slide, was the different versions that they were supporting. You can see Ubuntu 20.04, 18.04, Mac OS 11, 10.15, and so forth in there. So that runs on clause that you have in your YAML file tells GitHub what kind of a virtual machine to spin up to run that job on, to run that particular part of your workflow on. So you can run each individual job on a different operating system if you wanted to or needed to. These labels here, YAML's label, that's what you use in your code to say this is the version I want. Now they'll always have like a latest one, and you'll have to kind of look it up to see what it is, what the latest one is in there. And then over here, you'll see latest release and rollout progress. I should have put the URL on here where I got this. I guess it's actually at the top of this. GitHub.com actions/virtual environments. What the yellow and green here, that's their rollout. Basically, they're saying we're changing over our virtual systems to this new version. We are partway through it, or we're all the way through it if it's green in there too. So they're supporting these kinds of systems on the back end and periodically updating the versions of the operating systems. You are restricted to Ubuntu for the Linux systems there. If you want to do something else, you'd have to use a self-hosted runner. A little bit more about self-hosted runners here. Useful when you need more configurability and control. Allows you to choose and customize configurations. Can be physical systems, VMs, containers, and so forth in there. These, if you have a runner system, you connect it up to GitHub. You tell GitHub about it. You can go to the settings for your repository and say, here's my self-hosted runner. Here's the one that I've defined. If you don't, it connects to GitHub via the GitHub Actions self-hosted runner. It's actually pretty simple to do. It's pretty straightforward to do if you want to set up something like that. But it's automatically kicked off of GitHub. There's no connection to the actions after 30 days. Recommended to use only with private repositories. Now, this might seem kind of confusing at first, but think about it from a security standpoint. If you have a connection to your own self-hosted runner back at your company or on your system or whatever, and somebody forks your repository and you don't have things quite secure, then presumably they forked the repository and the action workflow gets executed in there and it's doing something to your machine, then they might actually be able to come back to your machine and do something either unintentionally or intentionally. So the guidance is more along the lines of if you're going to do self-hosted runners, better to do it with private repositories just to prevent some kind of accidental or intended abuse of that system. So, and over here on the right-hand side, this is some of the supported architectures and stuff for self-hosted runners in here. Again, I'll get you a copy of the slides. We'll make those available to you as well. GitHub Actions storage. The other thing that GitHub Actions do for you is they allow you to store artifacts. Artifacts can just be any kind of a file or any kind of combinations of files that you would want to use or share typically between jobs. For example, if you had a CI/CD pipeline and you did a build of something and your build produced, let's say, a jar file or a set of jar files, you probably want to have that persisted after that build step so you can run your testing on it, and persist it after the testing step or a testing job so you can run the deployment job on it. So again, if each job is running on a separate VM and that VM goes away afterwards, you need a way to persist those artifacts in there. So GitHub Actions has the concept of artifacts in there that you can say, I want to save this file essentially, or this set of content as an artifact. There is an upload artifact action. And so you can create things like in your job and say, I want to upload it, and you're uploading it to a storage space in GitHub. GitHub is going to persist this for you. This is also one of the things they charge you for. They charge you, can charge you for the amount of time, the amount of minutes and stuff in there, and also for artifact storage over a certain amount there. But the artifact is essentially a way of persisting objects or modules or whatever you have between the jobs in a workflow. How much does it cost? One of the first things people want to know. It is free. GitHub Actions is free for public repositories and or self-hosted runners. So if you are using public repositories or you're just hosting your own runners, it's free for you to use. For private repositories, each GitHub account gets a designated amount of free minutes and storage. You get a certain quota, and you start with that. And it depends, again, on the plan you have, and I've got the sort of the plans down there, and you can see the storage you get and the minutes. Now, the minutes are going to reset every month. So it's on a month-by-month basis. So they're going to reset back to 0 on a monthly basis. The storage does not. The storage just accumulates over time. So if you're using private repositories, like if your company is going to do its own GitHub Actions set up in there and use that, you have limits on what you can do. As well, then, in terms of the total storage, by the way, is the artifacts that we just talked about, plus any kind of GitHub packages. If you're not familiar with GitHub packages, it's kind of GitHub's answer to container storage or image storage, as well as like Artifactory, those kinds of things, modules and stuff. It's kind of a catch-all is the way I think about it in terms of packages like containers or dependencies in there. But storage usage is calculated for each month based on the hourly usage during the month, but there are per minute rates for that. If the jobs run on Windows or Mac OS on runners hosted by GitHub, the multiplier comes into play. And I wanted to make sure that I thought this was worth calling out here. If you are using Linux, you're basically getting the point, if it's like 0.008 per minute rate there, you get that. If you're using Windows, it's twice that rate for every minute that you're running on a Windows system. If you're using Mac OS, it's 10 times that rate. So, just be aware of that if you are in that space where you are doing things and you have to pay for the minutes you're using and stuff in there. If you're getting into the Mac OS area, there's the multiplier that comes into play. So, you don't want to be surprised by that. All right, so Actions integration with GitHub. By the way, if I keep talking here. If you have questions, feel free to raise your hand. And if there are questions, if somebody will remind me, I'll make sure to repeat it so the folks on the live stream can hear it as well. So integration with GitHub. As I said, there's the Actions menu now. There's the Actions tab there in the repository. When you go to the Actions tab, that's your one-stop interface for looking at the execution and the runs of the actions. The code itself, you can go back to the Code tab and look in that GitHub Workflows area. But the Actions is kind of the dashboard for your various workflows that you've set up. And again, all the runs through it, whether things were successful or not in there, you can drill down into it. You can go back and filter the different runs to see all the things that were executed in there as well. Now you can also drill into a particular run. So if you go to that Actions tab and you select a particular run, you can drill into it, and then you can drill into a job, a particular job, and then you can drill into the job, and you can actually then expand the steps that it ran, and you can see what was actually executed on the system itself. So you can see the code that was actually run on the system, what got executed in the operating system, what got executed by the actions you called, and so on. So again, you can just drill down through that from the dashboard to look at what happened. You can look at the history in there. You can see the history. You can filter it by branch or by the particular event that kicked it off or by the person who started it, the status, all those kinds of things in the dashboard there. You can also just type in things, like you can type in branch, a certain branch definition, kind of like a query criteria there, to type in there, and you can filter it that way, This becomes important when you start having lots of runs in there. When you start having lots of runs, or if you've got automated jobs, they're going to kick off these runs and have things cause lots of them to happen overnight. You might want to go in the next morning, for example, and just filter it by the ones that have failed. So you have that capability, again, through that sort of dashboard interface there in the Actions tab. To get a specific workflow run, you can click in there and you can look at, you click on the YAML file or the particular workflow, then go in and look at the particular jobs. And this also shows here the artifacts. Your artifacts get shown in the run of a particular job as well, the artifacts in there. And by the way, this artifact is whatever you call it. It's actually a compressed. If you upload you can have wildcard patterns, you can have multiple files, and then you can give the artifact a name in there. This one I called a greetings jar. It's just one jar file in this case, but it could be 10 different jar files. You can upload them and store them by patterns. And you have the job graph, as I said. If you have a lot of jobs in there, you can see the things that are going to run in parallel or maybe have different options. For example, in this one, we go sequentially through a build stage or build job, then to the test job, and then we go to either deploy to stage or deploy to prod or create a failure issue in there as well. So typical kinds of things that you would see in other systems, kind of the graph of the different pieces and how they all fit together. And then you can click on those, of course, and drill into them as well. When you drill into it, you can expand it and expand the different steps. One of the kind of little tips here I'll give to you is that if you can't, it's hard to see on this, but there are numbers over here, line numbers along the side. Those are actually linkable. You can actually click on that, copy a link, and you'll get a link to that specific number in the log, that specific line in the log that you can then share with somebody. So if you had a failure in there and you wanted to have a link to it to show to one of your colleagues, you can right-click on that and copy the link as well. Editing workflows, you may already know this, but in GitHub, when you have a file that you select, like if we select this YAML file for the workflow, there's a little pencil icon. Anybody ever use that to edit things in GitHub? You can actually do everything you want pretty much in GitHub there. You can use the pencil icon, and when you you edit a workflow file, you have your workflow definition over here on the left-hand side, and then you'll have also this area over here on the right-hand side, which is a way to search for particular actions. So these are actions that people have written or GitHub has written or authored to do particular things. So for example, if I want to find an action to download a build artifact or to upload one, I can type in this into this area up here and say upload or download, and it will filter this list. Now what it's actually showing me, if you can see the text there, it says search marketplace for action. Everybody's got a marketplace these days, right? They've got a marketplace for this, a marketplace for that. Actions are no different. GitHub has a marketplace for actions. Now you have the GitHub sponsored actions, the ones that GitHub created. You also can have actions that other people have created and put up onto the marketplace. Now, when we talk about security and things in GitHub Actions, we're not going to dive too deeply into that tonight, you have a choice. You can sometimes say, I only want to allow action workflows that were done by GitHub, or I want to allow action workflows that are done by validated users. To be honest, I haven't ever figured out exactly what a validated user is in terms of the marketplace. The marketplace has very sort of loose guidelines in terms of putting actions out there. So, I think as long as you don't have a name collision, as long as you have an action YAML, the metadata file, and as long as you have a README, they'll pretty much put it out there. All of that just to say, one of the things to be aware of with Actions, as with any kind of third-party piece you're pulling in, is, be aware that there's not a stringent sort of review going on for actions that are put into the marketplace. There's not security scanning and all of that going on. It's pretty much an open marketplace. Generally, if I'm looking for an action, yes, sir. Did you have a question?
Yes. Does when it says valid users, does it allow for you to be, like, say there's a particular group of users? Does it allow for that? Like, for you to be specific about who, like, say you have a group of users that you work with?
Yeah, the question was, for those on the live stream, if you are, when valid users, does GitHub Actions allow for you to say which users can have an action for you? I don't know that there's a way to specifically say a particular set of users. There might be with a code owners file. You might be able to use the code owners file and do that. I do know that when you have pull requests coming in, for example, and somebody has put a pull request in, it will give you the capability to say, you have to approve this first. Somebody with permissions in the repository has to say, okay, we can approve this or not. You can set it up to say either it is, you can run any action done by GitHub. You can run ones that are done by validated users. As I said, I'm not clear on what the validated users definition is. Or you can say, everything has to be approved. Any first-time contributor to your project has to be approved by someone in there. And that's one of the things, and I'm sorry, I'm going off on a little sidebar here, but that's one of the things to keep in mind if you have people contributing back through pull requests to your GitHub repository. You need to keep in mind, if they've made suggested changes to your action, to the .github workflows area, you need to really take a look at that. Be careful with that, right? Because again, most of the time it's going to be accidental, but it can still be something that actually causes issues, or actually, somebody was trying to inject code in there. There's a lot of things around security and hardening of GitHub Actions that we could go into, but we could spend an hour or two on that as well. But yeah, you can actually say, I want to approve any kind of thing coming in through a pull request and do it that way. Okay. But this is looking on the Actions Marketplace, and you can search through there, and if you find a particular one on there, then you can drill into it. You can go and look at the repository code. And I don't know, this is not a GitHub Actions thing, but this was really cool. I only found out about this recently, so I thought I'd mention it here. Anybody a VS Code user? Did you know that when you're in a GitHub file, you can hit the dot on your keyboard, hit period, and it'll bring up a VS Code browser interface, and you can edit it in VS Code there in that? Maybe everybody else knew that. I just learned that recently, which is pretty cool, actually. It's a much nicer interface. Now, the fun part is trying to figure out, how do I actually get out of this? How do I check it in and commit it and stuff in there? But if you are a VS Code user, or you want a more powerful editor, when you're in a file in GitHub Codebase, just hit the period key on your keyboard. It'll bring up the VS Code interface. And then you can go in and select the source control operation, type in like a message, and just hit the check mark. It automatically commits it back. It's very easy to do. All right, so updating workflows with pull request. When you're in the editor, you can update your workflows and go to commit. Bless you. Go to commit the file. You have the standard commit box. You can either commit it back to the same branch, or you can create a pull request. If you create a pull request in there and do that, then GitHub will run the actions that you have, the workflows. I still get that backwards. It will run the workflows that you have associated with the repository as sort of the pre-checks. So it's going to say, oh, you want to make a change to this code base. You have workflows associated with it. I'm going to go off, and before we say your pull request is good to go, I'm going to run off and make sure that all of the workflows that need to run with this actually work through that or actually work, okay? It's similar to the idea, you know, if you're integrating things and you have pre-checks built in for CI/CD, that kind of thing, you're going to execute them. So your workflows actually become sort of those pre-checks when you're trying to merge code in. So you might have workflows that do things like security scanning, or workflows that make sure, of course, things will, you know, build or validate, because you don't want somebody that's coming in with a pull request to be breaking your system. So the workflows that become your sort of pre-checks in there. Running your workflow manually, you can add what's called a workflow dispatch event trigger. What that really looks like is just in your on clause. And I know, again, it's hard to see on here. There is there's on push, on pull request. There's an on workflow dispatch inputs here. What that does for you, when you add that into your workflow, then when you go and look at it, you're in this Actions Dashboard tab, you'll have a little button there for that workflow that says Run Workflow. So then you can just start it from here instead of having to have a GitHub event that kicks it off. This is very useful when you're trying to prototype something, or when you're trying to debug it, or when you don't want to have to make a push or a pull request or something for that. You can just set up this workflow dispatch, and then you can hit that button, plug in whatever values you've told it to use there, and send that through and see it execute. So it gives you a way to run it without having to have a dependence upon an event in GitHub. Public actions here, the Actions Marketplace, as I mentioned, this is github.com/marketplace/actions. These are all actions. This is just a presentation layer, really. Each one of these actions is housed in a GitHub repository, just like anything else. But you'll have these different actions on here. A couple of things to notice. With these, this is sort of, like I said, the presentation layer, the nice user-facing page. There's a couple of things to look at on here. First off, you'll have like a little tag up here for the very latest version. There's also a button here, Use Latest Version. If you click on that Use Latest Version, and I don't know if I have it, yeah, there. If you click on that, you'll get a little dialog box with an example of how to use it. You can copy and paste that, put it in your code. It's going to be the most basic usage, basically just here's how you call this in there. A couple of other things to show you on here. There's a link here down on the right-hand side to the actual repository. This says Actions Checkout. So this is a GitHub provided action, provided by GitHub. And so the actual repository is github.com/actions/checkout. And one of the other things that's worth being aware of, well, you'll have information about what this is. You can also see things like the stars, how many people have liked this and used this. You know, it's kind of one of those things when you're trying to find an action that you feel more confident with. Typically, I'll look for ones that have been authored by GitHub, somebody at GitHub, and I'll look for ones that have, you know, a high level of stars, not a guarantee, but again, you kind of get a feel at least a lot of people have been using it. You can also see open issues, pull requests in there, so forth. One of the other things that I wanted to mention while we're talking here, check out v3. You'll see a lot of times, you'll see in a workflow file, use a particular action like checkout at v3 or checkout at v3. So there's kind of a convention that people are using in the actions here, which says a lot of times they will just have a major version. You know, if you're familiar with semantic versioning, the major version, version 2, version 3, and they'll move that version as they produce new versions of the action. So for all, if it's version 2.4.2 or something like that, it might be v2. If it's on to v3, you know, then so they'll use that only that major piece. Now, you have to be careful with that, okay? Because again, you're depending upon if you're just using like that v3, it's essentially a tag. It's a tag that points to some version, and presumably the owner or maintainer is moving that along. If you want to be absolutely sure that the code that you are using is the one you're getting, you can actually say use the action at the SHA-1 value. You can say the commit SHA-1. You could say a very specific semantic version. You could have a different tag in there. Again, the general sort of convention seems to be just, check out at V3 or V2 or something like that, the high level number. Just realize that that's going to be probably a moving tag from point to point as they roll it out. One of the security practices, if you really want to get very precise about this, is if you're looking at the action code, if you've gone through and reviewed the code and you feel like that code is okay, these are public repositories, then you might say, I want that particular set of code that was at that particular point in time. So you could say, use that action at the SHA-1 value. The version number you say in the uses clause can be anything that resolves to a get SHA-1 value. Let's see. Searching for a public action, again, you can search in when you edit the file, you can search in there like for upload, and you'll see you can find ones that have upload providers in there. Here's when I'll point out to you here, the upload a build artifact, you see it says by actions. If it says by actions, that means it's one that GitHub authored. It's one that GitHub provided. Presumably, that means it may be a more vetted action. It may be, somebody GitHub endorsed it, provided it, they put it out there. Otherwise, you'll see things like here's one by Veracode, by Google GitHub Actions, by Aqua Security, and so forth in there. And again, you kind of get back to this sort of thing of, well, which one do you want? Well, the upload to build artifact one has 1.1K stars. So generally, I look for something that is done by the GitHub Actions community, unless it's something just really kind of unique or something that I'm trying to use in there. So you upload a build artifact, and then it can take you to the page for it, and you can look at the marketplace listing. You can look then at the repository and so on. One other point here, actions themselves, when you have a GitHub action, they use their own workflows. So if you're looking at the definition of an action, like the checkout action or the Gradle setup action, Java setup action, they'll have actions in there typically themselves to do things like if you go on the Actions tab, this one has a build and test action, a check to distribution, a license action, or license workflow. I still mix up workflows and actions when I'm talking sometimes. But they use the workflows themselves in there. To define an action, you have the code for it, and then you have the action.yaml. So the action.yaml file, action.yml or action.yaml, either one, is what defines the interface to the action. It defines the inputs, the outputs, the environments it can run in. It can even define some branding. You can even have a little icon with it and stuff and substitute your own icon and brand it that way if you want. So the action YAML is the interface file that tells your workflow, these are the inputs that this action will accept, these are the outputs that it provides, this is the configuration, and so on. You can see kind of the different sections here, descriptions, inputs, outputs, and so forth. So let's talk just a moment briefly about custom actions. Actions are just GitHub repositories. They're just code that somebody wrote and put an action YAML file on it and put it together and said, hey, here's an action people can use. Go off and have fun. You can write your own actions. If you are interested in doing this, you can write your own custom action. 3 different types of actions you can create. Well, actually, I'll just talk about the general process. You would create a GitHub repository. You would clone the repository down, create the files or edit the files for it in there. You would add an action YAML, define the action YAML as the interface for it. Do a commit, do a tag of some kind. If you want to provide a tag like the V2 or V3 or something in there, you could do that. And then push it out there with the tag. So you just have to have the code for it, the metadata file, and so forth in there. And we're going to talk about in just a moment the different types of actions. If I define an action and I want to use it in my other workflow or somebody else wants to use it, all they have to do is say in the uses clause, here's the example job. You see the job name, example job, runs on Ubuntu latest. That defines the kind of virtual machine this job's going to execute on. And then we have in the steps, uses the repo name, the action name, and the tag. So anytime you say uses, The rest of that is just relative to github.com. If you say uses actions, there's an actions organization provided by GitHub with all the GitHub provided actions in it. But if I create a repo up there in my space, like Brent Laster is my GitHub ID, and then they put the action name there and then the tag, anybody who wants to use my action could use it by just using that. You can make it available. So you can create your own actions and put them on the marketplace. Again, it's really, as far as I can tell, a very loose vetting process. As long as you don't have naming conflicts, that sort of thing, you can put your own actions out on the marketplace and say, hey, here's my action, go off and have fun with it. Now, when we talk about custom action types, there's 3 types of actions, or 3 ways you can create your own action, depending on how comfortable you are with each of these different approaches. The first one is a Docker action. So basically the Docker action is, as the name implies, you can define either a Docker file to build the action or to build the code, to build the image, or you can specify an image, a pre-existing image to use. And so you just have a Docker plus the action definition, and you have the Docker file, and then in the action YAML, there's a runs area. The runs area of the action YAML says this is the type of action it is. You just say runs using Docker. You can have a Docker file specified, and it will go off and build the image when it starts this up and get the code down, or you can have an image that you specify in there in place of the Docker file. Docker's fine because it gives you the advantage of being able to, of course, encapsulate everything that you want, the environment that you want, all the pieces, all the benefits of a container, right, into a Docker container or image there. You also then can include any kind of specific version or so forth in there. The penalty you pay is that every time it starts with the virtual machine, it's going to have to pull the image, or it's going to have to build the image from the Docker file. So you get the trade-off of having that very controlled environment set up just the way you want it in the container space, or in the container, but you also pay a little bit more of a penalty in terms of having to build the image if you're using a Docker file, or at least pull an image if you specify an image. But that's one way to use it there. Another kind is JavaScript. If you are a JavaScript, anybody a JavaScript programmer in here? Yeah, a couple people. So you probably you know a lot more about this than I do. I'm not a JavaScript programmer. But basically, and I should mention the action, the Docker action, as indicated by the penguin, only runs on Linux. Okay, JavaScript action can be used as Node. You can run it on any of the operating systems they support there, and use Node.js. Now, the nice thing about the JavaScript piece is GitHub supplies what we call the Actions Toolkit. So it has a lot of different pieces, like core pieces or other pieces to do different things, and you can pull those into your code. And so you can get much more functionality and stuff by writing it in JavaScript if you know JavaScript to do that. So you have Node.js, and then you have an index.js file, index JavaScript file, where you can pull in, again, things from the Actions toolkit. 5 minutes? Okay, I'll hurry up, sorry. Require that, pull it in there, and then you have the action YAML, which just says using a particular version of Node and what the main file is. Then you have composite actions. Composites are basically steps. They are steps like you would have in a normal workflow, just grouped into an action. So you can have something as simple as a shell script file there. You can have, and your action YAML just says runs using composite as a type, and then just has a set of steps. So a composite action is another way you can also group steps together. If you wanted to take steps out of your main workflow and kind of separate them into a separate action, that's another way to do it. Workflow commands, I'll kind of skip through this. This allows you, but basically you can, from a shell script point of view, when you're running your workflow, you can just echo out, and there's a particular format, workflow command, that you can use to set things on the runner. You can use to set that on the runner and use it from there. Actions Toolkit, as I mentioned, Actions Toolkit is great for using with JavaScript. You're pulling in functionality. You can also use some of the functions with those kind of workflow methods in there. And toolkit packages, I'll skip that for now. Monitoring, troubleshooting, really quick. There is a debug and information you can get in there. If you're going to use debugging information, you have to set up a secret and they use a secret. There's GitHub secrets, and you have to set up a secret with a particular value. They use it more as a kind of a switch to turn it on or off in there. So you can set up and you can do things like dump out the context for the runner, echo out commands, and so forth. Yeah, this is just showing you going into the settings, creating secrets. There's an action setting there for secrets for action. Create a new secret, and you can put values into it. This would also be a way to store tokens or something that if you want to use something secure in your actions, create a secret, put the data in there. Personal access tokens, and so on. You can call other actions. You can call things from GitHub, like API requests and stuff in there. You can chain workflows together. You can actually use like a simple curl command to say, I'm going to call out to a GitHub API and call an action with a path through there. And that's it.